Hello, ladies and gentlemen, and welcome back. Root Beer here, and we're continuing our look at the 1968 Ontario Senior Paper with question number 6. So we've got two parts here. Part A, prove the identity nx times 1 plus x to the n minus 1 is the sum from r equals 1 up to n of r times n choose r x to the r. This n down here and this n plus 1 up here makes me think perhaps a derivative has taken place in some way. Now the sum over... So the nearest expression I can think of is 1 plus x to the n is the sum, using r I guess, 1 plus x to the n is this expression. This is called the binomial theorem. I don't need to prove that for them. This is a well-known result. So we've got the binomial theorem. But they want, so they bring down the n, but then they add in an x, and taking the derivative of the inside there is not going to bring out an x. So let's say derive both sides with respect to x. So the n will come down, you'll get 1 plus x to the n minus 1. This is sort of generalized power rule. And then some rule says don't really do anything here. Constants rule says don't really do anything with the n choose r. There's no x's there. But then we get an r x to the r minus 1, because again, power rule says bring the exponent down and decrease the exponent by 1. So this is very close to their expression. They have, it's r x to the r, so they've added an extra x, and that's why this x is here. Multiply by x, you'll get an nx here. Bring the r out where they wanted it, and then you get an extra x here. And so that just adds 1 to the exponent when we group them together. And there we go. We've proved the little result that they want. Okay. B part, from the identity in A, deduce a formula for the sum with n a positive integer, and here's our little sum here. So n choose 1 plus 2n choose 2 plus 3n choose 3 all the way up to n choose n, or n times n choose n. Okay. But that's almost exactly this. Well, of course, that's, otherwise they wouldn't say using the identity in A. So for a given n, by A, we see maybe we should start with the expression they've given me. So n choose 1 plus 2n choose 2 plus 3n choose 3 plus n choose n. Now this is very close to what they've got. And their expression starts with r equals 0, which is fine with me. So that's 0 and choose 0, because really you can multiply 0 by anything. You can just add in an extra 0. So we'll say this is, because we don't really want an x term, so I'll say this is 1 to the 0, 1 to the 1, because I'm just multiplying by 1s, and that's not changing anything. So this is the sum when r equals 0 up to n of r, n choose r, 1 to the r. And by a, this is the same as n, and then where my x is, I just write a 1, and then 1 plus 1 to the n minus 1. All right, it was n minus 1? Yeah. So this is n2 to the n minus 1. Okay, if we wanted to, we could, double check this. We don't have to, but we could double check this. If n is 1, the expression is just 1 choose 1, which is 1, and 1 times 2 to the 1 minus 1 is 1. How about, we'll do something a little grander. How about n is 3? 3 choose 1, plus 2 times 3 choose 2, plus 3 times 3 choose 3. That's going to be 3 plus 6 plus 3. 12. And according to my formula, that should be 3 to the times 2 to the 3 minus 1. 3 times 2 to the 2, and that's 12. So I'm really confident in my answer. You don't have to do that, but if you got a little extra time, it's always nice to double check your answers, especially if you think you just created a formula and you had to do a lot of arithmetic to get it. Okay, so that was question 6. Up next will be, looks like a trig question in question number 7.